Hi, in this video we will learn about the notion of angle between two vectors, and we will find a formula for that. We will use that formula to introduce a new notion called orthogonal vectors. Okay, so everything in this story comes from a classical theorem called law of cosine. What it says is basically if you have a triangle with sides A, B, C, then C squared is equal to A squared plus B squared. Up to here is basically the Pythagorean theorem, but it's not just that. If you have an excessive thing, you have to get rid of that. So that's 2AB cosine of theta. That's the theta angle between two sides A and B. Okay, so this is the law of cosine. As I said, this is kind of generalization of Pythagorean theorem. And the way we will use this is that, okay, so if I have a vector u and another vector v, then we know that u minus v, the vector u minus v, forms the third side of this triangle. So if we apply the law of cosine here, so apply law of cosine, what we can get is that length of this side, which is u minus v, the length, squared is equal to length of this side v squared plus u squared, length of u squared, this is the other side, minus 2 length of u, length of v, cosine of theta, where theta is the angle between these two vectors. Well, then we look at the left-hand side a little bit closely. So left-hand side is length of u minus v squared. But we know that the length of any vector you give me, we can find it by dot producting that vector to itself. And then use the dot product properties, basically distributivity of dot product, and what we will get is u dot u minus u dot v minus v dot u plus v length v vector v to itself. But this thing, we know that u and v, these are the ones that we dot product vector to itself, so we get length of u squared, and for that part we get length of v squared. But on this side, you remember the commutativity of the dot product. We can switch the order here. You write u dot v, and then we will have 2u dot v, is actually negative 2u dot v. Well, left-hand side is equal to that, right-hand side is equal to that, then we can set these guys equal to each other, yes? And the result is that u plus v, well, I forgot to put the square there, so these are squared, minus 2uv 2u dot v is equal to, let me go a little bit further, u squared v squared length of u squared minus 2 length of u length of v, and then cosine theta. Well, this cancels with that, that cancels with that, and then we have negative 2u dot v is equal to negative 2 length of u length of v cosine of theta. Well, these negative 2's can be cancelled also. Let me write the formula we just found. This is u dot v. We know how to find that. U dot v is you multiply the corresponding components and add them. But now we are proving that it is equal to length of u times length of v times cosine of theta, the theta angle between these two vectors. This is a good new formula, and we can use it in two ways. One of the ways is that, okay, see, u dot v, as I said, we had a recipe for that component wise. So you do the component using the components, but now the right hand side, if someone gives you the length of u and length of v and the angle between them, you don't need to know what are the components of u and v. So that right hand side gives you u dot v in a very different way than the u dot v, the definition of u dot v gives you. Okay, so let's do an example and see how this works. Find u dot v if length of u is 3 and length of v is 2 and the angle between u and v is pi over 4. Pi over 4 is in radian, so remember in degree this is 45 degree. Okay, so we have the formula there. U dot v is equal to length of u times length of v cosine of theta. Length of u is 3, length of v is 2. Oops. 2 cosine of pi over 4. You have to know cosine of pi over 4 is root 2 over 2. And then, well, you can cancel these two, and this is 3 root 2. And that's how you find dot product of these two vectors. Well, you may ask yourself, what kind of angles I have to know cosine for? Well, this table is the main values for which you have to know the cosine theta, 0, pi over 6, which is 30 degree, pi over 4, which is 45, pi over 3, and then pi over 2, which is 90 degree. Cosine of theta, for 0 is 1, for pi over 6 is root 3 over 2, for pi over 4 is root 2 over 2, sometimes you may see 1 over root 2. Cosine of pi over 3 is 1 over 2, and cosine of pi over 2 is 1. This is the table of cosine and values of angles that you have to be able to find and recognize backward. So if someone gives you cosine, you have to be able to go backward also. Okay, so that's the first thing. Then, well, one of very good uses of this formula is that, okay, I can in general, well, do this thing. This is u dot v, length of u, length of v, cosine of theta, and then divide these two to the other side. So we can get cosine of theta equals to u dot v over length of u and length of V. And this is a formula that we can use in general. So in general, in general, for any two vectors from what, u and v from Rn, well, your book says we define the angle between, all right, just we have here, this is that cosine of theta, the angle between these two, is given by this u dot v over length of u, length of v. Note that we know how to find out product of vectors in Rn, and we know how to find their length. So these are two numbers, you divide them and you will find the angle between them. Let's do an example. Find the angle between given vectors. Okay, what are these vectors here? I have here 2, 0, and 1, 1. Another pair is 0, 1, 1, and 3, 0, 3. Well, let's just find this one. We have to use the formula. The formula is there. Cosine of theta, the angle between, is dot product of 2, 0 and 1, 1 over length of 2, 0, length of 1, 1. This is 2 times 1 plus 0 times 1. And length of 2, 0 is 2 squared plus 0 squared. The length of 1, 1 is 1 squared plus 1 squared. Okay, so the numerator is 2, denominator is root 4 times root 2. And root 4 itself is 2, so we can cancel this with that. This is 1 over root 2. If you rationalize the denominator, you get root 2 over 2. So you look at the table here, this is pi over 4. So theta for the first pair is pi over 4. For the second pair, I will do a little bit faster now. 0, 1, 1 dot 3, 0, 3 over length of 0, 1, 1, 3, 0, 3. And then this is 0 times 3, 1 times 0 plus 1 times 3. In the denominator, we have 0 squared plus 1 squared plus 1 squared. The other one is 3 squared plus 0 squared plus 3 squared. And this gives us what? This is 0, this is 0, numerator is 3. Denominator, this is root 2 and this one here is 9 plus 9. This is root 18. Okay. Something about root 18 is that, well, you can see this as 2 times 9, and it's called root works nicely with product. So this is 3 root 2. So what we found here is cosine theta is 3 over root 2 times 3 root 2. And as you can see, this cancels with that, and you get 1 over root 2 times root 2, which is root 2 squared, and that is 1 over 2. What is the angle whose cosine is 1 over 2? You can check the table. Theta is pi over 3 for this second pair. So you have to be able to use that formula and find that cosine for the angle between. Well, as a result of this thing, we have a note. If the angle is pi over 2, then what will happen? Well, then u dot v is going to be length of u times length of v. This will be cosine of pi over 2. And that means that u, but we know that cosine of pi over 2 is 0. And right-hand side will be whatever the length are, you multiply by 0, you get 0. So u dot v is going to be the number 0. What does this say? This says that if two vectors are perpendicular to each other, then their dot product is 0. On the other hand, if u dot v is 0, then cosine of theta, the formula you remember, this is u dot v over length of u, length of v. This is going to be 0 over length of u, length of v, and then that is 0. Well, there's only one thing that we have to be careful. U and v cannot have 0 length. In other words, if their length is 0, well, that's a vector 0. Vector 0 doesn't have any angle with any given vectors. So then we have the theta is pi over 2 if and only if u dot v is equal to 0. And then when that is the case, we say that u and v are orthogonal vectors. So they are orthogonal. In other words, the test for being perpendicular when they are in the standard position is u dot v equal to 0. The terminology we would use is that they are orthogonal. In other words, their direction is perpendicular to each other. Let's do one example before I finish this video. Example: find all values of k for which two vectors k negative 1 2 and k minus 1 4 and negative 1 are orthogonal vectors. Well, what you need to know is that, well, k is some variable. Yes, for different values you will get different vectors, but for some k's, apparently the question asked for those k's, that these two vectors are orthogonal. Well, we have to find those ones. Orthogonal means that this dot this is 0. But what does that mean? We know dot product is multiply the corresponding components and then add them. So this needs to be equal to 0. So we have k squared minus k. This is minus 6 equals to 0. And that means what? Well, we have a quadratic equation for k. We have to solve it. Well, use either quadratic formula or use the decomposition that I'm trying to find two numbers which add up to negative 1. And when you multiply, you get negative 6. And these numbers are negative 2, negative 3 and plus 2. Then as a result of this guy is 0. As a result of the other factor, this is 0. So that means that k can be either 3 or k can be -2. For two values of k, these two vectors are going to be orthogonal. Very quick wrap up. We find a new formula for u dot v, in which we had the cosine of the angle between. Then we use that formula to define a way to define angle between two vectors, or find the formula for cosine of the angle between two vectors. And then out of that came out the notion of orthogonal vectors, the vectors whose dot product is equal to 0.